So this video is on Friday's classwork, just to make sure everyone knows how to do these problems. So on this first one, you are going to be trying to find the sum. You need to pay attention to whether this is arithmetic or geometric. When you have your variable in your exponent, it's going to be geometric. So this is going to be a geometric sum. And then we need to decide if this is going to be infinite or finite for geometric. And when we see this infinity, we know it's going to be infinite. And so for the infinite sum, the formula is S is equal to A1 over 1 minus R. Okay. Now, our A1 is what we're starting with. In this case, we are starting with the fifth term. So instead, we're going to do A sub 5 because we're going to start with the fifth term, and then we're going to do our formula. The R is always the thing that is being raised to the power. And so in this case, our R is going to be 0.8. And in order for an infinite sum to exist, your R has to be in absolute value in between 0 and 1, and 0.8 is. So we're going to use this formula. So to find A sub 5, let me just do this over here. To find A sub 5, I put 5 into the equation. And here, let me move it over a little bit. I don't need that far over. Oops. So I'm going to put 5 into the equation. And so when I put 5 into the equation, I am going to end up getting 60 times 0.8 to the 5 minus 2. And if I put that in the calculator, 60 times 0.8 raised to the 5 minus 2, or 3, I end up getting 30.72. So that is my A sub 5. It is 30.72. So I am going to do 30.72 over 1 minus my R, which is 0.8. And I'm going to put that into my calculator and get my answer. So 30.72 divided by the quantity 1 minus 0.8. And I get 153.6. So 153.6 is my sum. Now on number 2, on this one, I need to decide if this is arithmetic or geometric. Looking at it, I'm leaning towards geometric. I feel like I'm probably multiplying. So to figure out what my R is, I take my first term, I times it by R, and set equal to the second term. And then I'm going to solve. So I'm going to multiply by the reciprocal of 1/3, which is 3 over 1. And when I do that, I'm going to get R is equal to 3/4. Now I want to make sure, or 0.75. And so I want to make sure that that works. So if I take 1/4, and I multiply it with 3/4, you see that we're going to get 3/16. So it does give me that. So that works. Okay, so I found my R. And it is geometric. Okay, it is geometric. So this is going to be geometric. And then again, we want to decide if it's infinite or finite. Because it's going dot, 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 it's going to be infinite again. And so the infinite one is A1, your first term, over 1 minus R. And our first term is 1/3. And it's going to be 1 minus 3/4. And so I'm going to do this without a calculator. It's going to be 1/3 over 1/4. And then if I am dividing by a fraction, I can take my 1/3. And if I'm dividing it by 1/4, I times it by the reciprocal. And for my answer, I'm going to get a 4/3 for my answer. And that's my answer. Okay, so on number 3, so for this one, we need to decide if this is arithmetic or geometric. To me, it looks like it is arithmetic. So let me see. If I take negative 47 and I'm adding something to get 7, I am going to add 47 to both sides, and I get D is equal to 54. And so I see that that is going to work. My D is going to be 54. So for this, and again, this is going to be arithmetic. This one, they're giving us the last term. The last term is this. We need to figure out what that term is, because the formula for an arithmetic sum is S sub n, where n's how many terms you're adding. We don't know that because I do not know what this is. And then we take n over 2, again, that same n, times our first term and our last term. We know our first and our last term, we just don't know our n. So to find it, we are going to be using this formula. So we are going to go a sub n is equal to a1 plus d times n minus 1. And so I'm going to go 1141 is equal to negative 47 plus 50. Plus better. Plus 53, 54, n minus 1. Okay. And so I am going to add 47 to both sides. So 1141 plus 47 is going to give me 1188 is equal to 54 times n minus 1. I am going to divide by 54. And I'm going to get 22 is equal to n minus 1. So n is 23. So that means this term up here is a sub 23. That's my 23rd term. So when I'm finding my sum, I'm going to be finding S sub 23 is equal to 23 over 2 times my first term, which is a negative 47, and my last term is 1141. And I'm going to put that into my calculator. So I'm going to take 23 times negative 47 plus 1141, and all that's going to be divided by 2. And I end up with 12,581 as my sum for number 3. For number 4, we want to figure out what sum this is. Okay. Or I'm sorry, what n is in this. And so we need to figure out if it's arithmetic or geometric. So on number 4, we have to decide if this is arithmetic or geometric, and we want to find n. We want to find what term this term is. Now looking at this, when these are all nice numbers, all of a sudden we get a decimal, I'm thinking geometric. Okay. And so to figure out what I'm timesing by, I'm going to take 4800, which is my first term, times r equals 3840, and see what my r is. So 3840 divided by 4800 is 0.8. And let me just make sure that works. So I'm going to times that with 3840. And it works. Okay, I'm getting the right numbers there. Okay, so for a geometric one, if I'm trying to find a particular term or which term is a certain number, a sub n is equal to a1 for geometric times r to the n minus 1. Okay, I know my an, it's 1966.08. I know my a1, it's 4,800. I know my r, it's 0.8 to the n minus 1. And I'm going to solve this. Okay, so the first thing I'm going to do is divide both sides by 4,800. So I'm going to have 1966.08 divided by 4800, and I get 0.4096. So 0.4096 is equal to 0.8 to the n minus 1. You can either log both sides and have that be kind of base 10 logs, or you can rewrite this in logarithmic form. So I'm going to show us how to do it by changing it to logarithmic form. So to write this as a logarithm, this is going to be log, and this is my base. Okay, so log base 0.8 of 0.4096 equals always our exponent. And so our exponent is n minus 1. And you can put this into the graphing calculators. Now, if I'm putting that into the graphing calculator, you do not use this log button right here. That is base 10. Ours is not base 10. Ours is base 0.8 if I'm doing it this way. Okay. So to get a log of any base on this calculator, I'm going to press the alpha and window. Okay. And if you press alpha and window, number 5 is log base anything, not just base 5, base anything. So I press that, and so you can put a base in. So I'm going to put 0.8 of 0.4096, and it's going to give me 4. So this whole thing is a 4 is equal to n minus 1. So I add 1, and my n is 5. So this is the 5th term. Next problem. So on number 5, okay, so I showed you guys the other day how to do this using systems of equations. I'm going to show us how I myself personally would do these problems. So when I teach sequences to my integrated 1 students, I show them how to write it in different forms. So this one is arithmetic. So if it's arithmetic, when we first learned an integrated 1, we did a sub n, and we always start with our zero term, not our first term, our 0 term. We always start with a sub 0. And then we were adding our d n times, okay? But sometimes it was hard to go backwards. And so I taught my integrated 1 students, and this is how we personally are writing ours this year. We start with our first term. And then if we're starting with our first term, then it's d times n minus 1, because now we're 1 off of that. Okay, so whatever term this is, it's n minus that number. So for example, in this case, I know a sub 7. I'm going to do it in a different color. So I know a sub 7 is 148. Okay. So that means if I want to start with a sub 7, I can start with a sub 7. And I am still going to add d. I'm always adding d no matter where I'm starting my sequence. But instead of this being an n minus 1, if I start with my first term, it's an n minus 7 if I start with my 7th term. So I'm going to use this equation. So I am going to go a sub n is equal to 148 plus d times n minus 7, because I'm starting with my 7th term. Then I am going to take this 35th term. I'm going to put that in for my a sub n equals 148 plus d, and this was my 35th term, so I put 35 in for n, so this will be 35 minus 7. I'm going to minus 148 from both sides, and I am going to get 1,484 is equal to, and that's going to become a 28d. I'm going to divide by 28, and I get d is equal to 53. So I'm adding 53. That is my d. Okay, I'm not done with my equation, but they want me to find my equation. Okay, so at this point, you could go into this equation and write an equation for a sub n, starting with your seventh term, which is 148, adding 53, n minus 7 times, and that would be your equation. Now, if you want to go and write it like we normally do with the n minus 1, I'll show you how to do that next. So again, this is an acceptable equation. It is an n minus 7, because this is my seventh term. If you needed it where that term, that 148 was instead your first term, you can find your first term, take 148, which is our seventh term, put it into A1, which you would be trying to find, plus our D, which is 53, times n minus 1. So that's going to be 6 minus 1 because that was our seventh term. So we're going to get 148. Let me get my calculator back over here. $148 is equal to A1, and then 53 times, sorry, this wasn't a 7, this was a 7 minus 1, so it was a 6, sorry, 7 minus 1, so that's going to be a 6. So it's going to be 53 times 6, or 7 minus 1, and we end up with 318, so this is plus 318. I'm going to minus 318, so 148 minus 318 gives us negative 170. So a sub 1 is negative 170. So if you want to use your a sub 1, your a sub n equation, just like the one I just wrote above in pink and circled in black, you can use your new a sub 1, which is 170. We're adding 53, because that's our D, and then n minus 1. If I was to clean either one of these up, these are both, the one here in pink that I circled and the one that I circled in black, both of them are the same equation. Okay, one starting with your seventh term, one starting with your first term. Okay, last problem. On number 6, same idea, this is geometric. The other day, again, I showed you guys how to do it using systems, but you can do the same process I just did. So again, a sub n is equal to a1 times r to the n minus 1 if I'm starting with my first term, but I'm starting with my sixth term. So if you're starting with your sixth term, I could start with a sub 6 times r to the n minus 6, and I could set it up that way. So I'm going to do that instead of doing a system right now. So I am going to take this one here, which is 370.6, is equal to my a sub 6. So I'm using this one right now is what I'm going to use. Okay. So my a sub 6 is 1181 times r to the n minus 6. Okay. Now mine is going to be 17 minus 6. So I'm going to get 370.6 is equal to 1181 r to the 11th. I'm going to divide both sides by 1181. So I'm going to take 370.6 divided by 1181. And hold on a second, 370.6, 1181. Yeah, just making sure I have the right numbers. Okay. And actually, this is what I'm going to do. I'm going to, instead of having to write that decimal there, I'm just going to leave it like this right now. I'll put it in my calculator. And then I'm going to take my 11th term. Find the 11th root. So I'm going to take the 11th root of that. So once I take the 11th root of that, now I'm just finding r. So to find the 11th root, you're going to do math. Number 5 is one way to do it. And so 11, and I'm going to do 370.6 divided by 1181. I end up getting 0.8999. Okay, so let's see. I don't think this is going to give me a nice Yeah, not a nice fraction at all. So this is going to be 0.8999. So I'm going to round up to 0.9. So 0.9 is going to be my R. Okay. So if I want to do what I did in the last problem, I could write my A sub n equation, starting with my sixth term, which is 1181, timesing it by R to the n, and my R, sorry, we just found, which is 0.9, raised to the n minus 6, because I am using my sixth term, okay? So that is an acceptable equation. Again, if you want to find your A1 and do this equation, and I'm kind of doing right here in black, then that one I would do 1181 is equal to A1 times my R, which is 0.9, raised to the n minus, to the, sorry, 6 minus 1, because it's my sixth term. So I'm going to have 1181 is equal to A1 times 0.9 to the fifth. And then I can divide both sides by 0.9 to the fifth. So 1181 divided by 0.9. Now I'm just going to put it in parentheses. 0.9 raised to the fifth. I end up getting 2000.03, let's say, is my A1. So if I did not want to write it in the form I wrote it in over here, okay, I could write it, and I'll put it in blue here. A sub n is equal to my first term, which is 2000.03 times 0.9 to the n minus 1. That is acceptable if you want, but you could leave it in the form up here. I'll recircle it, this one right here. So hopefully this kind of makes sense to you guys. If you prefer to do it the systems way, I can show you on Monday.